So use inverse operations to write the inverse of each function. You should also be using what form? I think your directions have one more thing in them. What does it say? Don't you say write the inverse in proper notation? Yeah, what's the proper inverse notation? Yeah. Inverse notation, you have to have F inverse. Okay? And yours have that reminder on there, so when you see in the directions, it says write the inverse in proper notation. That should be a light bulb going off that, oh, I better have that as part of my answer, okay? So that's what you should have for all of them. So 1, you have 1 over 15x plus 2/3. Remember, these are all linear, so we want them in the form y equals mx plus b, or in this case, f inverse mx plus b, so you can see your slope and your y-intercept. 2 is negative 1/4 x plus 5 over 2. For 3, the f inverse is x minus 1/2. For 4, f inverse is negative 12x. For 5, f inverse is 4x plus 12. And for 6, f inverse is 2x minus 1/3. Okay, let's pick out at least one of those to do together. Which one do you guys want to do? Yeah.
I just had a question.
Yeah.
Aren't we supposed to do reverse order of operations? So like for number 5, when we
Yes.
add,
So this one, when you're doing the reverse order of operations, if it's a fraction where you have the top over the bottom, it's really like this. You have parentheses separating the top and the bottom. They're two separate entities, so you do have to move over the denominator first. Okay, but you could also, if you wanted, you could split it up, x over 4 minus 12 over 4, and you could do it that way. Okay, so when you're doing one like 5 and 6, your first step would be to multiply by 4. So 4x, oh, sorry, I forgot to make this my y. Okay, would equal y minus 12, and then you'd have 4x plus 12, and then you'd have the f inverse. You could also divide it, like I said, and you could have y over 4 minus 3. And then if you did x plus 3 equals y, like that, over 4, then here you would end up multiplying by the 4 and then distributing x plus 12. Okay? And you could do it either one of those ways. Yeah, the fractions like that have different rules when you have the variable in it. Okay, all right, you guys ready for the graphs? Graphing each function, or other ones from 1 through 6? All right, so for these, you had to graph each function and then write and graph its inverse along with the line of reflection. Make sure that you label each line. So you have the inverse, or the function, the inverse, and then the line y equals x. Okay, and then you're going to make a table for each function. Now, when you do make the table, you don't have to do that first. In fact, for this one, remember, these are linear. How do you graph a linear function? Where do you want to start when you're graphing? Yes. Start at your y-intercept, and then the second thing is use your slope. Okay, so for negative 4, I started at negative 4, went up 2 over 1, up 2 over 1, up 2 over 1, and then I am going to give you a straight edge, because you do have to span the entire graph. Some people stop before the line of reflection. Whatever graph you're given, you need to span the whole thing. Okay? And then once you graph the line, now you can write your points. Like you can see mine went out of order because I started at 2, 0. And then I went to 1, negative 2, and then 0, 4, negative 1, negative 6, negative 2, negative 8. And then once you know that, the inverse is just going to be those switched. Okay, and then your F inverse, you're going to have to solve by switching x and y, and then solving for y. So you're going to add 4, divide by 2. So x over 2 is 1/2 x, 4 over 2 is going to be 2. And then you're going to put that in inverse notation. All right, so we'll do something similar for 8. So you start at -2, okay, and then you're going to go, then you're going to use your slope. So it's up 5 over 2. And what do you notice about the scales here? Yeah, this one counted by 2. So if you're going up to 5, you're going to go 2, 4, 5, and then over 2. 2, 4, 5, over 2. Okay, and then 2, 4, 5, over 2. And then the other one would be off the chart, really, for that. And then, like I said, I will give you your straight edge. And then you can just do your points from there. So if you have -2, you are at -7, at 0, we were at 2, or -2. Looks like at 1 we were at 0, or 0.5. That's what it would be. At 2, you're at 3. And then at 4, you were at 8. And then with the other ones on the graph, I would just plug something in. Like if you plug in 1, 5 over 2 times 1 is 2.5. 2.5 minus 2 is what? 0.5. So you can have one more point on there. And then for your inverse, you're just going to switch them. And really the tables for these is just so that I can see what your points are, because it's just hard for me to see sometimes on the graph, especially when you have a bunch of lines. And then how do you graph the line y equals x? Like, how do I know where this goes? The line of reflection. Yes, it always goes through 0, 0, and up 1 over 1. So it's going to be that diagonal line. Okay, and then in this case, when you're solving to find the inverse, x equals 5 over 2y minus 2. When you're solving for that, you have 5 over 2y. How do you move this over? How do you move over a fraction? Yes. So remember, we'd have to do that part without a calculator. Do we remember how to distribute a fraction? 2/5 x, and then 2/5 times 2 would be what? 4/5. Okay, so then your inverse would be 2/5 x plus 4/5. Now this would be a case where I would be like, I don't really want to start at 4/5. I like whole numbers. So why don't we just use our table? Right? So then I could do -7, -2, -2, 0, 3, 2, 8, 4, 1/2, 1. Right there. And then again, I'm going to give you a straight edge so you can absolutely use that. And there you go. Okay, question? Yeah, any question? Oh, yes, you can. Yeah, because it is. It's going to keep going forever. Yeah. And then just make sure you label what each one is. So your f of x, your f inverse, and then your y equals x. All right, now let's talk story problems. when you have a story problem and you are finding the inverse, it is important that you do not switch the variables. Okay, so do not switch your variables. That's because they are tied to specific values. In this case, the C is tied to the cost of the item, and the D is tied to the discount. Okay, so you cannot switch those around. Okay, so the employee discount is determined by this formula. So I would box this in or highlight. Use the inverse of this function to find the cost of the item for which Dan received an $18 discount. So the inverse function means that you are going to solve for C. So you're going to solve for the other variable. Okay? And we're going to go over how to do this the most efficient way. So if you have D equals 0.15 on the outside of C minus 10, instead of distributing, okay, which I think would take more time, I would just divide by 0.15. Because then these are going to cancel. You'll have C minus 10 equals D over 0.15. Okay, and then you'll just add 10 to both sides. So D over 0.15 plus 10, that's going to be your final answer. 0.15 plus 10. Okay, if you did distribute, that is fine. Your answer is going to look a little bit different, but again, it would be correct. You could have C equals D plus 1.5 over 0.15. So if you have that, that's fine. And some of you put this in Y equals MX plus B form. You don't have to with the story problems, but if you did, you could. Okay, so then do you have 1 over 0.15, or did you divide that out?
Somehow I got 20 over 3.
But do you have 2 of them, though?
Sorry?
Do you have 2 of them, though? Do you have 2 terms, I mean?
Oh, yeah, I have 20 over 3 D plus 10.
Okay, so you must have just converted that into a decimal. This would be 2/3 times 6. Yeah, that'd be okay. And then the 1.5 divided by 0.15. Yeah, and you said you got the plus 10? Yeah, that's fine. Okay, but you can also just leave it like that. That'd be fine. Yeah, it's like 15 over 100, and then you simplify. Yeah, you can do it. You can do it like that. All right, now it says evaluate the inverse function when D is 18. So all you have to do is plug this in, right? So C equals 18 divided by 0.15 plus 10, and you will get what? What was your final answer for this? 130. Okay? So that's going to be the cost of the item if the discount is 18. Now it says, what was Dan's final cost? Well, if it originally cost $130 and he received an $18 discount, what do I do with the 130? Yeah, just have to subtract 18. Okay, so he's paying $112. Okay? So, again, on your quiz, it's no calculator. So instead of giving you something like that where you would have to use a calculator because it's decimals, I would give you a problem where you wouldn't have to, like in your homework. Do you guys remember in your homework the story problem that you did with Fahrenheit and Celsius? I think it was Celsius equals 5 ninths F minus 32. And you had to find the inverse. So the inverse would be solving for F. So it's a very similar process, right? How do I move over what's in front of the fraction? I mean, here, the fraction's in front. How do I move over what's in front of the parentheses? Yeah, you could, but do you really want to do 5 times 32 divided by 9 without a calculator? I wouldn't. So how do you move over the fraction? Multiply by reciprocal. Which is the same as dividing by that, but less to think about, right? Because if I multiply, 9 and 9 cancel, 5 and 5 cancel, now I just have f minus 32 over here, and this is just 9/5 times c. Okay, and then what's my final step? Yeah, okay, so this is now my new equation. So then, I know there was a decimal in your homework. I wouldn't give you that. I would say, okay, well, if the temperature in Celsius is 35, find the temperature in degrees Fahrenheit. So let's practice that without a calculator. So that would be 9/5 times 35 plus 32. How could I do that with the least amount of work possible? Because I could multiply by 9 and then divide by 5, but that's going to take me a little longer. What can I simplify here? Yeah, the 5 and the 35. What's 35 divided by 5? 7. So 9 times 7 plus 32. Isn't that going to be a lot quicker? Yeah. Okay, so if it's 35 degrees Celsius, it is a balmy 95 degrees Fahrenheit. Yay. Okay, so again, this is one that you did in your 4.2 homework. You are welcome to go back and look at that. Okay, find some problems, or you can find some problems that have that, and we good to go.